Hello guys, I just wanted to summarize about vertical asymptotes and holes and move on to horizontal asymptotes and oblique asymptotes. So go ahead and take these notes. You can pause the video as much as you'd like, and I apologize again if you hear my dog or cat or husband in the background. I tried to get them to be quiet. So let's look. We did one example in class. We're going to look at two more examples for vertical asymptotes and holes. So if you have this rational function, again, rational function means you basically just have x's in the denominator. Could be a constant up top or another function with x's. So the first thing we do is we factor completely the top and the bottom if we had to do the top. So before you cancel out the factors x minus 5, take a look and see what makes each factor equal 0, because those values are values that you want to throw away from your domain. So in this case right here, I want to throw out, my domain is going to be all real numbers, but I'm going to throw out those values that make my denominator 0. So even though I'm going to cancel this factor out and be left with a 1 on top, I'm not going to do anything with that 5. I'm going to include it though in the value that I'm going to throw out from the domain. Okay, so there's your domain. And then the function that you have left is 1 over x plus 1. And what happens with this is that x equals 5, which would be that value that we threw out from the domain. You're not going to have a vertical asymptote there. You're actually going to have a hole in the graph. So since a hole is a point, we need to find the y value that goes with this x. So once we have our reduced function, 1 over x plus 1, substitute 5 in for x and get 1/6 as the y. So that means our hole is at the ordered pair 5, 1/6. And any factor that remains, wherever that factor equals 0, at x equals -1, that will be your vertical asymptote. Okay? Let's take a look at the third example. Again, pause the video whenever you need to. The third example here, the bottom again needs to be factored. As I had mentioned in class on Tuesday, cheat. And if you see that this is the numerator and you have trouble factoring, try using 2x minus 1 as one of your factors in the denominator. And then you'd be left with x plus 4 as the other factor to get a -4 when you multiply. And now, again, before you throw out or cancel out those factors, let's throw out those two values that make my denominator 0. So my domain will be all reals except 1/2 and -4. Now I can go ahead and cancel, and I'm left with 1 over x plus 4. The x value that I had from canceling, which would be 1/2, that's where you're going to have your hole. To find the y value, again, substitute in 1/2 into that reduced equation. Use your calculator if you need to, but 1 over 4.5 will give you 2/9. So that means your hole is going to be at this ordered pair. The factor that's left, where that factor equals 0, which again is the other value you threw out from the domain, that will be your vertical asymptote, x equals -4. So we can also have horizontal asymptotes. And what a horizontal asymptote does is something you've already learned what to do. So it actually describes what's happening to our graph as we approach both positive and negative infinity. So it's what you've been learning to do for a few months now. As x approaches positive infinity, y approaches, and then you would fill it in. So that's actually what we're doing here. And we're going to have a horizontal asymptote in only 2 cases. Okay? So since we basically have 2 polynomials on top of each other for a rational function, the first case is when the degree of the polynomial in the denominator is greater than the degree in the numerator. When that happens, I want you to think of approaching either a positive or a negative infinity. As you let x get infinitely large in either the negative or the positive direction, this denominator is going to grow a lot faster. Even if it's negative, it's going to grow a lot faster than that numerator because you're cubing a large number as opposed to squaring. So think of it as being bottom heavy. So that means that the ratio of the top to the bottom, as x gets infinitely large, either negative or positive, that denominator's going to get huge, which means the fraction will approach 0. So in this case, your horizontal asymptote will always and forever be y equals 0. So when, again, the degree in the denominator is higher than the degree in the numerator, I know for sure that the horizontal asymptote will always be 0 because the bottom will grow faster than the top, making the fraction itself become smaller and smaller and smaller and approach 0. We'll learn in class how we know if or when we can cross a horizontal asymptote. You can never cross a vertical. So if we need to, underneath vertical asymptotes, we can never cross them because they are where your function is undefined and you can't take that out of the problem. Horizontal asymptotes sometimes are crossed. Okay. So case 1 again was when the denominator had any degree higher than the numerator. That fraction will approach 0, so that's the equation of our horizontal asymptote. Case 2 is when the degree in the numerator equals the degree in the denominator. In that case, they kind of grow. These terms grow at the same rate. These terms here, the linear term and the constant term, they don't really have an effect when you're squaring a huge number. They don't affect that value too much. So if you can imagine these two growing at the same rate, because they're going to be the same number, then all I'm going to get left is the ratio of their leading coefficients. So anytime I have equal degrees in the numerator and the denominator, I will always have a horizontal asymptote at the ratio of the coefficients of those powers. So in this case, my horizontal asymptote is y equals negative 3/4. Make sure that you're putting y equals and not HA equals. They are lines that become part of the graph. So make sure you're putting y equals for horizontal and x equals for vertical. So if you take a look here, we had one case when the degree in the bottom was bigger. We had another case when they were equal degrees. The only case we haven't touched on yet is when the degree is greater in the top. When that happens, we have something called an oblique or a slant asymptote. You could use either word, and either abbreviation is fine. Okay? And it will occur when the degree of the numerator is higher. I see I left that word out. Occur when the degree of the numerator is greater than the degree of the denominator. Okay? So again, they occur when the degree of the numerator is greater than the degree of the denominator. Usually it's going to be 1 degree higher, but it can actually be 2 degrees higher, but usually you're going to encounter 1 degree higher. To find the equation of this asymptote, the oblique slant asymptote, use long division. That's why we just studied it. And what you're going to do is you're going to throw away or disregard the remainder. So if this is your polynomial function, your rational function, we use long division like you just did on your exam, and you did very well with it, we get a remainder here of 43. Now, we normally would write the remainder like this. But again, the horizontal and slant asymptotes, they tell you what's happening to the graph, the end behavior, as x gets really, really large. So the reason that we throw away the remainder is because as x gets really large, this fraction, 43 over a really large number, whether it's negative or positive, it's a huge large or huge negative number. That fraction will approach 0. So that's why we throw away the remainder. So that means our slant asymptote has the equation y equals 2x plus 5. And as with horizontal, sometimes slant asymptotes or oblique asymptotes can be crossed. We'll learn in class on Thursday how to check for that and when to know it happens. Doesn't happen all too often, but it can happen. Okay? So one thing I want you to think about is, look at that, is that a rational function can have either a horizontal asymptote or a slant asymptote, but never both. It can't have both because the asymptotes compare the degrees in the numerator and denominator. And for a horizontal asymptote, the degrees are either equal or greater in the bottom. And for a slant, the degree has to be larger in the numerator. So you can't have both asymptotes at the same time. Verticals can go along with either of these. But in terms of a horizontal and a slant, you can only have one or the other. Okay? So go ahead and, again, play this video again if you need to. Pause it when you need it to be paused. And take some notes on it. And when we come back to class on Thursday, we're going to recap this and spend all day practicing graphing and finding our asymptotes. All right? Thank you. Bye.